Okay, welcome. Couple people finding seats, good. Thank you guys for smushing in all the aisles. I know it's a crowded room. Thank you for being here. My name's Steve Teixeira. I work on the engineering team in the operating systems group, working on the Internet of Things. Yes, we have an Internet of Things team. You may have heard. I'm just delighted to be able to talk to you today. I've got a ton of stuff to go through. I've got I don't know how many pieces of hardware up here. I'm going to try and get through as many of them as possible and show you guys some cool stuff. I want to start by pointing you to some other things that might be relevant resources. Since you're here, that tells me you're interested in IoT. And I want to make sure you know about some of the other sessions that are relevant to IoT. So don't miss Goog's keynote. He'll show some really cool stuff there. Don't miss Todd Holmquist Sutherland's presentation. I think it's right after this one if you want to see more on the Azure side. Today I'm going to focus a lot on the device side. I'll talk a little bit about the cloud, but I'm going to focus mostly on the device side, just in the interest of time. Pete Brown and Jason Olson have a really cool session around music, and Viroff will show some new hardware. I'll give you a little bit of a sneak peek in a moment, but particularly for builders, that's a session you're not going to want to miss either. How many of you saw the keynote? How was it? Awesome. Yeah, I didn't pay for that either. I thought it was really good too. One of the things that I thought Terry did a great job making the point of, here at Microsoft, we're trying to bring together a consistent set of devices and services, enabling people and businesses to do more and be more. But increasingly, these devices and these services don't look like the computing things that we normally think about as computers. Right? They don't have keyboards and monitors or mouses or even screens, or maybe they have some interaction model that's completely different. And so that's the kind of stuff I want to start talking about today and give you an idea of both where we are as well as where we're going. There we go. I'm a big fan of quotes. So I kind of want to start there with a couple quotes. Anybody know where this quote came from, a chicken in every pot? No guesses? KFC, that was a good one. Those aren't chickens. I've heard they're beakless creatures. I don't know, I read that on the internet. It must be true. It wasn't Stalin. It wasn't FDR. It wasn't Herbert Hoover. It was Louis IV of France. It probably sounded way cooler in medieval French. Who's the guy that said KFC? I'm going to give you headphones, because that was the best answer. Some Nokia headphones. Thank you. Great answer. It wasn't the right answer. We thought it was Herbert Hoover, but our crack IoT research staff, Wikipedia, told us it was actually Henry IV. Fast forward a few hundred years. The original Microsoft mission, as I think was reiterated in the keynote, was about getting a computer on every desk and in every home. And as an industry, we all just kind of really overachieved that particular goal, right? Now we have computers in our pockets and on our wrists. And I've got 86 of them on the stage with me right now, given only one desk. What I aim for, though, is to get to the point where we can have a computer in every pot and in every chicken. And I think computers are getting small enough, right? Moore's law is just relentlessly marching on, shrinking stuff. Power requirements are going down. Our ability to write software that takes advantage of these new innovations as a hardware is getting better and better. We're able to all kind of stand on the shoulders of the giants that came before us and build increasingly cool stuff. And so it represents a lot of opportunity for the industry. Just to give you a little bit of numbers here. $1.7 trillion, according to IDC, the estimated market size for IoT. Now, this counts software and hardware and services, so it's kind of the whole thing. But you can see across a lot of devices, or rather across a lot of verticals, manufacturing, telecom, consumer, there's going to be a lot of demand. With these devices shrinking, getting smaller, ubiquitous connectivity, whether that's long-haul connectivity via cellular, whether that's short-haul via Wi-Fi, emerging standards like 6LoWPAN, there's all kinds of stuff coming out that's going to create a lot of opportunity that everybody in this room has an opportunity to go participate in that. One of the things that that I ask myself a lot, and we found some numbers here about how many devices are there going to be, like just roughly. This number came from a couple years ago, a study done by Ericsson. They said in 2020 there's going to be 50 billion devices connected, and that's like chickens, pots, industrial turbines, that's a lot, all devices, right? But then that wasn't good enough. So Morgan Stanley, like a year later, said, actually, you guys were off by like 50%. It's really 75 billion. There's going to be 75 billion connected devices. And then a couple years, or actually I think like 6 months after that, another IDC study came out and said, no, the number's actually 212 billion connected devices by 2020. And I can't tell you exactly what that number is going to be, but it's big. It's a lot of computing devices. It's a lot of hardware that's going to get built. It's a lot of software that's going to get designed to run on this. Roughly in the neighborhood between 50 and 212 billion sockets for software and for services. I wanted to also contextualize what we mean when we talk about devices. Too often when we talk about IoT devices, people think in this, like near the bottom of this pyramid. Now, what this pyramid represents is kind of the world of devices that are not traditional computing devices. They're not PCs or tablets or laptops or game consoles. They're all the other stuff. And so if you kind of look at that world, what you find is at the top, there are these devices that tend to be bigger. They tend to be higher value. And down at the bottom, there's these devices that tend to be smaller and more disposable, if you will. And there are a lot more of the things at the bottom of the pyramid than there are things at the top of the pyramid. So just to set that context, I want to walk you through a little bit of just the attributes of these things. And of course, in real life, this is not, there are not hard lines between these things, right? This is a gradation from top to bottom. But speaking in generalities, things at the top are things like POS terminals, of which I have one right here. This is a point of sales terminal. There are things like ATM machines, MRI machines, things that are basically traditional PCs wrapped up in a different skin to do a different purpose. They tend to be x86-centric. They tend to be PC-like in nature. They tend to run apps like a PC. And some platform products that we have in Microsoft are Windows Embedded Industry 8.1 and Windows Embedded Standard, which are the version of Windows that you would go run on these things. And I'll show you a little bit more about that version of Windows in a bit. If we look at the second group includes things that look a little bit more like tablets and phones. They're kind of mobile devices, but they're not consumer tablets and phones like we would think of them. They're not like my Lumia 920 here. Maybe they look a little bit more like this thing, which I'll talk a little bit more about in a moment. But some scenarios that we would use these for are industry handhelds. So think the package delivery guy has this handheld that he or she will use in order to scan packages. Or a POS tablet. Think in a store scenario, someone with a tablet running around taking your credit card information so you don't have to wait in line. We call that line busting. That's another scenario. And those can be ARM and x86. They tend to have a shell experience on the OS. And they also have a consistent app model experience with the rest of the Windows app ecosystem. And we have a product called Handheld 8.1 that fits that need. Now as we get smaller, we start to think about things like gateways or wearables or cars or I call it panels, like the things that we would use to control climate or to control AV or to control the security in our home. They're small, sometimes they're headless, sometimes they have a small screen. They tend to be both ARM and x86, although probably more heavily ARM. And hardware is very diverse, big ecosystem of hardware, and tend to not have a Windows shell experience or any kind of shell experience. Usually your experience is like one app or one or two apps that you'll use with these kinds of devices. These look like Windows Embedded Compact or Windows Embedded Automotive, both things I'll talk about in a little bit more detail in a bit. And then finally, things at the very low end. Micro devices, controllers, fixed function devices, sensors, actuators. These things are small. Typically, in terms of the bill of materials, the BOM, less than $10. Like these are very inexpensive to produce devices. They tend to be ARM-centric in this space, often kind of Cortex-M style ARM, the microcontroller side of ARM, and usually headless. And we have we participate in an open source product called .NET Micro Framework, which I'll talk a little bit more about in a moment, that addresses this part of the market, because typically you don't even run an OS down at this scale. Like, the memories are too small to even go with an OS. So this is kind of the lineup, and I feel bad for you guys way over there in the corner. Like, I'm trying to come out here and engage with you and give you like some eye time, because there's this big pillar. I don't know who designed this building, but my apologies for the building design. The other thing I'd like to mention, and Terry showed this earlier, is it's not just about all these devices. That's the things. It's about the connectivity between these devices. We are currently working on a set of M2M services in Azure, machine-to-machine services in Azure that enable these devices to do interesting things with one another and with people. There's also a bunch of stuff you can do on Azure today with Service Bus, and Todd's talk later is the right one to go to if that's a topic of interest. But really, we find there are three key capabilities that people need when they talk about, okay, I have this cloud service, I want to talk to my devices. What are the capabilities I need in that cloud service? One is device management. I just need to be able to kind of interact and do things with my device. And I'm not talking about device management in the sense that we might think of it from an IT standpoint, like how is the health of my OS on this device? Is my virus checking software up to date? It's not so much that. It's much more about the health of the device as not as a computer, but as a whatever that device is. So for example, if it's a vending machine, I don't really care about the health of the antivirus on that. What I care about is, am I out of Planters peanuts in the vending machine? That's kind of this idea of device management, being able to understand the context that the device is in based on the data that that device renders. Command and control. So you see this in intelligent systems, networks of devices. When these devices do this, I want to see that happen, and I want to go tell these other devices to do this other thing. That would be an example of command and control. And finally, data analytics. With all these devices, I believe the term is spewing telemetry, or maybe that was a wind bug thing. But anyway, they're spewing data somehow. I want to be able to do analytics over that data, both in real time and batch analytics. If I get enough data, it becomes kind of a traditional big data problem. And I also want to be able to do predictive analytics. As I build a big corpus of data, I can start to build out intelligent systems that are able to do things on their own. That when I receive these signals, the system is smart enough to go, that means that something bad's about to happen. Let me go prevent that bad thing from happening, potentially without human intervention. So when you get those capabilities, you can do a lot of things. You can do monitoring of devices. I can continuously monitor my vending machine. And when it's running out of Coca-Cola syrup, I can make sure I can go proactively send someone to go refill the syrup. Things like content distribution. So you think a scenario like a piece of digital signage up in Times Square or something like that. You want to be able to remotely send content to that device and have it be constantly up to date. Remote access to the device, so I can get in and I can do things to control that device. And then to manage and deploy configurations. I want to be able to provision them easily. I want to be able to manage at scale. I just wanted to show you a number of the Windows devices I have. In addition to my consumer devices, I showed you the POS terminal. That's this thing. It's got a little mag stripe reader to swipe a credit card on the side. There's a little screen in front. There's also a screen in back if I want to do like a price check type deal. I've got a number of enterprise industry handheld devices, of which I'll show you a number of these in just a moment. I've got a .NET Micro Framework device sitting inside of here. Really cool. I'll show you that in a minute. What else do I have on stage? I have one of these Galileo boards that you saw driving the piano earlier. We're going to do cool stuff with the Galileo later. I've got a Sharks Cove development board that we'll talk about in a minute. Whole bunch of devices. Oh, I have to show you this one too. This is a wireless router. You might even be able to see the brand on the side. It's a Microsoft wireless router. Who knew that Microsoft used to make these things? We did back in the day, a few years ago. That actually runs Windows CE, the thing that we now call Windows Embedded Compact. I got that from one of my engineers that I work with in Redmond before I left, and he really was reluctant to part with it. He's like, no, they don't make them like this anymore. You don't understand. This is like the best router I've ever had. Take care of it. So I have to be really careful not to break Dave's router. I thought I'd just kind of go through and talk about each of these types of devices and types of platforms in the context of where they sit in the pyramid. So if we think about .NET Micro Framework, kind of occupies mostly this low end. At the very low end, maybe sometimes not so much, but typically higher up we do. But here you're talking about inexpensive devices, low tens or high single-digit dollars in BOM cost, as little as 64K of RAM, sometimes without a memory management unit. This project is open source. And this is a project that's been around for a while. It started at Microsoft. We went and took it open source. The thing I want to announce to you guys today is we're going to double down and increase our investment in Micro Framework. And there are a few key things that we think are really important that we do with Micro Framework going forward. One is improving runtime performance. We have a number of customers that come to us and say, love Micro Framework, love that I can use C# and have a .NET experience to target these little devices. I need performance to be a bit more competitive with native code. Can you help? And we want to help with that. Thank you, sir. Checks in the mail. One guy liked it. Modern language support is another one. Increasingly, cool libraries and cool code samples that you'll find on the web require newer language features, say generics. And those aren't present today in Micro Framework. So we need to go and we need to do the work to fix that so that when you find random cool code, you can actually use it in Micro Framework. And also updated Visual Studio integration. It should be that when a new release of Visual Studio comes out, you should automatically be able to enjoy all that goodness of the new Visual Studio from developing Micro Framework. I spent a lot of years working on Visual Studio, so that one is near and dear to my heart. I just wanted to call out one product that I think is really neat and innovative that uses Micro Framework, which is NetDuino. NetDuino is an Arduino hardware-compatible device. That's the thing that's sitting inside of this streetlight. It lets me have that kind of open sourcey maker hardware experience, but it lets me do it from the comfort of a Visual Studio C# development experience where I'm not kind of tied to some different vendor embedded tool chain that maybe isn't quite what Visual Studio is, that I can stay in the environment I really like and have a productive experience to solve the problem I want to solve and not kind of fight memory management and the software underneath. One piece of breaking news that I'd like to share with you guys is talking with Chris Walker, who runs the company that ships these. They're doing an Azure SDK to be released this spring. So for everybody working on NetDuino devices, you'll be able to very easily connect to some Azure service that you have provisioned in the cloud and be able to have this Internet of Things based on NetDuino devices. So I want to do a demo for you guys, and this demo requires a little bit of setup. I'll show you the picture. This is the inside of this light. I took this with my cell phone. I recommend, by the way, you stay away from the intersection of 6th and Howard for the next couple of hours. Had a little trouble securing the light. Let me call out a couple things. So inside of this, we've screwed in a NetDuino 2+ board. So that's doing some interesting things. Connected to that, we have a little relay module. So each one of these lights, it's a big real light. It's not like an LED thing. So this is a full 110 volt type deal. And this relay allows me to control switching on those circuits from the NetDuino, which is pretty cool. And then up in the top, you can't see it. It's kind of behind the parabolic reflector here. There's a little Bluetooth module that's very, very tiny that plugs into the NetDuino that allows me to do Bluetooth communication. So imagine, for example, you're stuck at a stoplight and the stoplight spoke Bluetooth. You could just tell it to go green, and that would be way better, right? And of course, I would be remiss to not point out the fact that the shocky bits are down at the bottom, and you have to be really careful what you do with your screwdriver, because you could get shocked by touching it to the bottom part. Top part's generally pretty safe. So let me then switch over here. And by the way, I did that whole song and dance to show you guys all of the interesting hardware, not just to show off the hardware, but also to solicit your sympathy, so that if I have some catastrophic hardware failure, you'll go, yeah, but there was kind of a lot of hardware there, so I understand why it didn't work so well. So what you see here is Visual Studio. I've got a Visual Studio solution with a couple projects. One is I have a Netduino project, and the other is I have a Windows Phone project. Now, what I'd like to be able to do is I'd like to be able to write a Windows Phone app. I would like that Windows Phone app to speak Bluetooth. I would like that Windows Phone app to talk to my Netduino in here and be able to switch my lights on and off. That was kind of my goal. So just to walk you through a little bit of the source code, there's interestingly very little source code, which I think is sort of the magic of the devices at this scale, is that I can really focus on doing cool and interesting things with the devices and not get so hung up on the, the plumbing. I can focus on the problem that I want to solve. And so what we do here is we provision a few ports using the GPIO, the digital I/O ports on the device. And those are the things that we use to signal the relay, turn on, turn off. So there's one for green and one for red and one for yellow. And there's also an onboard LED that's on the device itself that we just use to flash it just for debugging purposes. So I create a serial port that is connected to Bluetooth, and I'm just going to receive information serially. In this case, I send one-character commands over Bluetooth to be able to say, yes, go red, go green, go yellow. This is the data received code. It's actually pretty straightforward. I read some bytes. I kind of do an index of and look for a termination marker. Depending on what that termination marker is, it calls this do something function. And if we switch over and look at the do something function, I start by turning all the lights off. Oh, by the way, this was a fun bug for me to fix. You see where it says write true to the pin? You have to write true to the pin to turn the light off, and write false to turn it on. I couldn't figure out, like, this is not working right. Which, if you're connecting an LED, by the way, instead of a relay, it's the opposite. So, live and learn. With that bug corrected, simple. Like, the bulk of the code looks like, OK, good. Write a true or false as appropriate, depending on whether the character I get through the port is an R, an O, a G, or an X I use to just turn off all the lights. And that's basically it for the Netduino code. It's quite straightforward. If I come over and switch to the app, and you'll see the app here. It's loading up in the designer right now. The app is pretty straightforward. It allows me to connect to a device over, I'll look at my paired devices and connect over Bluetooth. And then I have some circles I can push to enable the lights. Let's just take a quick look at the source code. So just a few interesting things with source code. One is I do some work up in advance to figure out which devices I'm paired with. So peer finder, alternate identities. I'm going to look for what devices that this might be paired with. I'm going to go ahead and try and create a Bluetooth connection, opening a socket. And in that socket, I'm simply going to write bytes to it as I want to do interesting things. And once I do that, it becomes as simple as this code up above, which is writing an O or an R, what have you, to that socket. And then I have some code. This go-to state thing is really just UI housekeeping code that turns the circles in my UI the right color. But that's about it. What I'll do is I will try and make this work. So let me go ahead and I'm going to run the Netduino version. And I'm connected to this via a little USB cable here. So if all goes well, I should get the debugger stood up. I find the fact that the USB noise just happened a little bit disconcerting, but I'm going to ignore it and assume it's all going to go to plan. All right, so it looks like I'm up and running. It looks like I found symbols. Let's come and switch over here. Now, this is my personal phone. This is not a demo phone. You can learn a lot about people from looking at what's on their phone. There's my wife. There's one of my sons. But let's go run this app. All right, I've got it down here. This is the app that I wrote. All right, so the first thing I want to do is I want to connect to this Bluetooth device. So let's hope this part works. OK, allegedly it worked. And by the fact that Rafa is bathed in an eerie disco glow tells me that something's working. So let's see, can we turn all the lights off? Is it happening for me? Yay. It was OK applause, I guess. I've had better, honestly. All right, thanks. Wow, whistle. Now I feel like accomplished and attractive because you whistled at me. Thank you. All right, let's see if we can. There we go. All right, I want to talk about another thing, which is connected car. Connected car, if you think about where it is on the pyramid, I'm killing you guys. That's awesome. Let me not kill you by, how's that? Yeah, good. You were like squinting and a little bead of sweat was coming down. It was sad. So connected car kind of fits in the space between small devices and mobile devices. In some ways, it looks kind of like a phone or a tablet. In some other ways, it's kind of this low-level thing that controls the flow of data that travels across the CAN bus in the car, which is the internal bus on which like all the data exchange on a vehicle happens. What's cool is, Microsoft, we've been in this space for a very, very long time, probably more than 15 years. A good chunk of cars on the road today actually run Windows CE or Windows Embedded Automotive. Here's a sample of some of the vehicles that use Microsoft OS today. The way that folks have been doing this to date is using embedded as sort of the core operating kernel upon which they would build their own user experience value adds. So we didn't really have a point of view in the past on, well, what should we paint in the dashboard of the car? The question is, what are we going to do going forward? Like, we've been doing this for a while. We're going to keep doing this. Like, people really rely on us. But what are we going to do going forward? And so what I'd like to talk about today is how we're going to approach this going forward. So today, in addition to the in-vehicle infotainment operating system that we have today, we're going to add a brought-in device approach to our strategy. So that means that given some in-vehicle infotainment system that might run embedded compact or might even run another vendor's operating system, we're going to work to create a world where I can bring my Windows device into my vehicle. And I'll do questions later. I want to get through everything, but I definitely want to talk later. I can kind of jack in, and I can get a projection of what's going on my phone up on the in-vehicle IVI, or in-vehicle infotainment system. There's a connectivity standard here. There's more than one, but the predominant one is called MirrorLink, of which our new friends Nokia were one of the early proponents. And it really gives people the best of both worlds. The IVI knows more about your car than anything, so a brought-in device like a phone can never usurp the value of the IVI, because that's wired into your vehicle. At the same time, if you think about, I keep my cars for maybe 8 years, and my technology, my computer in my car kind of gets longer and longer in the tooth every year, but I change my phones like I change my underwear, like I'm getting a new phone all the time. And so I really want to be able to use the best of my own personal technology in the IVI where it's appropriate. And so here's kind of a conceptual view of what that looks like. A few things that we really try to address. So this problem is definitely not as simple as like blast the phone UI, bit-blit my phone up on the IVI, call it done. It's a pretty complicated problem. We've been studying this for quite a while, given our history in this space, and working with auto manufacturers to help us. There are really 4 key issues that need to be addressed as you're building a UI that sits in the car dashboard. One is cognitive load. Driving a car is a complex activity. What you need to do is enable people to do the things that they want to do while driving, and do that in a way that allows them to keep most of their gray matter focused on the task at hand, which is driving. So whether I'm making a call or text message or listening to music or whatever that activity is, I need to be able to do that with minimal cognitive load. The other is glanceability. There's actually some research here that says that you really have about 2 seconds to take your eye off the road before the chances of something colossally bad happening go very high. And so when you build user interface that is designed to sit in a moving car, it needs to be optimized for this less than 2-second glanceability factor. There are a bunch of other human factors as well. For example, when I have my phone, usually I can put it right in front of my face. I can use it with my thumb. Works really well. When I'm using it in my car, typically that's out at arm's distance. Often it's either below or above my up near the dashboard. So just differences in screen size and interaction model require a different mode of design. And then finally, input modes, like I don't really want to touch tiny things that I might be able to touch with my finger on the phone. That's not the right experience for my car. In fact, most of the time, the right experience for my car is voice. And I think you saw Cortana today that voice is actually getting pretty good as an input mode to really understand your intent and to be able to put that into action for you. So I'd like to show you guys, though, a little bit more than just a screenshot. What I'd like to do is show you a little bit of a demo. I'm going to mute my music in my car, and I'm going to switch over to make sure I've got the right device here. So in much the same way that an auto company would create a concept car to show latest technology, latest design, human factors integration, think of this as our concept car for the IVI. Imagine this as a projection of my phone up on my vehicle screen. Here I've got the start page for my car, if you will. You can see I've got some key information about speed limits and things I need to know right now. I'm able to pin things that are important to me right here, so common tasks I can go and I can pin. I'm able to go and maybe select different views. Maybe it's not navigation. Maybe I care more about now playing. I've got a really nifty swishy sound when I move around. One of the things you notice here is there's this opportunity for application builders to also participate in this ecosystem in a couple different ways. You can imagine that maybe if my car's in park, I can run any kind of arbitrary app, project that up to this screen. But if my car's in drive mode, one of the things that we will aim to do is enable application builders to write apps that conform with good safe drive mode behavior and safe drive mode user interface standards so that they can participate here as well. So interesting stuff. If I can go to the maps experience, it's really small, but you might be able to see that the map is currently centered on Pacific Raceways right now near Seattle. That's not a joke, by the way. This isn't something that we just dreamed up in our UI lab and I'm kind of showing it. We actually put this in the dash of cars and we use it in two environments. One is we have a full wraparound simulator with kind of eye tracking so we could tell where people are glancing as they're using this kind of thing and driving in the simulator. But we also really do take this to the racetrack and try and see, okay, does this really work like we plan on it working? But of course, I can choose to go somewhere else. Maybe I want to go home and go ahead and start. Oh, start no worky. This is why it's a concept, ladies and gentlemen. So let's head back here. Try this one more time. Hey, look, it was like I never crashed. Sorry, that's a bad term to use here, isn't it? Let's head over to, looks like Moby. Let's go ahead and pause Moby while we're working. So we saw navigation. The other thing that's interesting is communication, and there are a few different modes of communication that would be important to me. One is obviously calls, so I should be able to touch the tile to somebody that I want to get in touch with, make that call. I wonder if David's home, I'm not sure.
The number you are trying to reach is unavailable. At the tone.
Okay, I guess David's not there. The other thing I can do is take a look at frequent contacts. I can look, for example, at my messages. I could say, this text message, yes, go ahead and read that one to me as an example. Coming over to media, you can imagine integration with all of my media sources, certainly those on my phone, but also ideally those that exist in my car as well, to be able to tune, for example, to a particular radio source, or maybe even to Xbox radio. To be able to go through my collection of media on my device and manage it and play it from there. So that's just a taste. Again, more of a concept, but a concept that we're working very, very seriously on so that we can bring the best of these two worlds, the IVI and my broad-end Windows device together. Great, so let's talk a little bit about Embedded Compact. This is the product that some may know as Windows CE, the former product name. Occupies a really interesting niche in these small devices, and lots of devices are built every year in Embedded Compact. Usually small footprint, often kind of industrial style devices, things where people need reliability. Often they have some real-time constraints that they need to adhere to. They need a lot of silicon flexibility, so there's BSPs from many different boards running from ARM through to Intel. A number of the devices I have up here are CE devices. I mentioned the gateway here. This is actually an industrial, it's a modular industrial PC. So there's no moving parts in this. It's air cooled. There's a multi-core processor in here. So this is another interesting example of the stuff that folks build with CE. Almost lost my clicker. Announcement I'd like to make is an update that we've done very recently, and we're announcing today for Embedded Compact 2013. A couple key things are really important here. In addition to some new BSP support, support for Visual Studio 2013, so I can do all of my development in the most recent version of Visual Studio. Also, we did a lot of work around Wi-Fi, so you'll find much improved Wi-Fi connectivity in this release as well. Really excited about this announcement of this version of Windows that really helps us target this range of kind of small, connected smart devices. Now if we move over to mobile and look at some mobile devices, this is an interesting space. I think we're seeing a couple different trends. One is we see a trend where a lot of people are looking at consumer devices and wanting to use consumer devices in commercial situations, which works pretty well for a lot of cases, where I can just take my consumer device, I can connect, for example, a magstripe reader to it, I can do credit card swiping, all that stuff works pretty well. But there are a lot of cases where that doesn't work super well, and I'll talk about that in just a minute. Before I go into product details, though, another announcement around Windows 8.1. So you saw the announcement earlier of Phone 8.1. We also have a product called Embedded Handheld, also announcing release, and a number of really cool features here, some of which I'll demo in a moment. Just to go through them very quickly, assigned access is this idea that for a consumer device, it's fine to say, like, this device is hard-coded to me as an individual. But in a typical scenario, say manufacturing or retail or shipping, creating a device that's hard-coded to individual people isn't the best way to do it. Instead, what people tend to want to do is to do role-based access. To say, well, assembly line workers should use devices in this way, and managers should use devices in this way, and salespeople should use devices in this way. And you can actually all use the same device in many cases, but you really want to customize what that device looks like and does based on the task worker. Enterprise application development is another key feature here. One of the neat things that happens here is, in addition to support for kind of the modern app model and converged applications, the ability to sideload enterprise applications very easily. Device management, really optimized for mass deployment. I can configure devices en masse. I can create a configuration that sits on an SD card. I can plug that SD card into my phone, boot with it, and then suddenly I've created the configuration that I can use for task workers inside of my enterprise. And then a bunch of support for standard industry peripherals. The idea that I should take, particularly in retail, any kind of peripheral that is industry standard, plug it into my phone, and have it just work. Here's a few examples of devices that are going to be shipping on Windows Handheld 8.1. So you see a couple from Bluebird, one from Panasonic, this ToughPad. A few stats you can see about, these devices, sometimes they have cellular capability, sometimes they're Wi-Fi only. They usually have big batteries. They're usually highly ruggedized. These are pretty beefy devices. Maybe it would help if I just kind of walk through a little bit. So let me turn this on. There we go. So here you see this is a copy of 8.1 handheld. It's got Cortana, the whole nine. This is kind of looks like a consumer phone, but It's got a bunch of other interesting capabilities. Ruggedization is probably the key one. Anybody in the audience have maybe an iPhone, Android device? I wonder if you guys could do this with me. Nobody took me up on it. So that was like a double drop, like onto the stage and then off the stage, and then it still works really, really well. These things are actually designed to be dropped from like a 10-foot distance onto concrete. You could literally drop them in a bucket of water and they'll still keep going. Like, these are the constraints that you want for a real industry-grade device. Consumer devices, again, great to use in some scenarios, but where you really need things to be ruggedized for a particular environment, nothing beats this kind of thing. So what I would show you is an interesting feature. Let me switch over really quickly to Visual Studio. So here I've got an app that I've been working on that is the login app for this particular device. My login app allows me to change roles on a particular device. So imagine in a work environment, I have a table of chargers with devices. No matter who I am in that company, I can pick up a device off that. I can say, yes, I'm this kind of role in the company, and the device just kind of configures itself for me. I can do all kinds of interesting things when I do that. What I'm showing here is, this is an XML document that describes that set of capabilities. So again, the way I would provision this is I would do this XML document to lock down and configure my device appropriately. I would provision that device, and then I would set it so that people could use it afterward. But I can do lots of interesting things with this. For example, I can choose to pin certain applications to the taskbar. I can choose to remap the buttons. So I can say, these kind of people can use the camera. These kind of people shouldn't need to use the camera. I want to enable or disable, for example, the search button for a particular class of users. I can do that from this XML configuration file. I can define exactly what those roles are in my organization. And then once I've done that and I've provisioned devices, I can then programmatically, as a developer, go in and say, okay, what kind of role is the currently active role? And then be able to potentially modify the behavior of my application based on that knowledge. If I switch over, I'm doing the multi-device dance here. Let's see if, where's my, by the way, feed 4 is called Elmo. Didn't really, it's weird that this device is called Elmo, but it's memorable. So here I can choose the login. So let's say, for example, I want to sign in as a guest. Yes, let me sign in as a guest. Now that I'm signed in as a guest, I have a start screen that has no apps on it. I can slide over and I have just a few different things that I can get to from the app screen. I can go to settings, for example, and you can see that I can only get at a handful of settings. So I've been able to kind of lock this device down pretty well based on my role. I can also do things like, notice I'm pressing on, let me move it up, I'm pressing on the search button here, which if you're like me, you do on accident sometimes. And nothing happens because I've locked out that behavior from this particular role as well. Now let me change to an associate and sign in. Now as an associate, I have a different start screen, some different apps that are available to me. If I go to the app screen, you can see, okay, yeah, many more apps that are available. I've got this price check app in particular that seems interesting. Let me try and use the camera for this device. Yeah, so I push the camera button and it doesn't work. But if I hold down the search button, instead of going to Cortana or to Bing, I've been able to remap the behavior of that search button to go to the search button that makes sense for my enterprise or my business. And so in this case, it would be a price check search that I'd want to go to. And then finally, I can look at settings, and I have the selection of a few more settings from within this. If I go back to the login app, let me go ahead and sign in now as a manager. I'll sign in. And you can see when this comes up, as a manager, I now have access to the applications that are more important to me as a manager, including Angry Birds, Halo, Bejeweled, FIFA Soccer, that sort of thing. I also have access to sort of the full set of apps on this, and I think, yeah, I've enabled the camera button as well for the manager role. All right. And Windows Embedded Industry is the product that sits kind of at the top of that pyramid. It's the thing that we use for controlling larger devices, more PC-like devices. In fact, Embedded Industry is really a full copy of Windows, plus some advanced features for lockdown and for branding. So some of these lockdown capabilities that I showed you in the context of a handheld device, you get similar capabilities in the context of one of these devices that is more PC-like. And I can also change it so that maybe if I don't want the Windows brand to show through because that doesn't make sense for my device, I have the ability and flexibility to do that. Bunch of devices, again, today use Windows Industry, ranging from robots on the factory floor to MRI machines, X-rays, ATMs, point-of-sales devices. Lots and lots of devices use this today. One other announcement I wanted to share is the release of Embedded 8.1 Industry Update. So with this update of Windows 8.1 in the spring, we have a companion update for Embedded, and that brings a few different things. One is this improved developer experience. So yes, you get the one app ecosystem, but also the ability to do side loading, the ability to do inter-process communication, so that if I have a modern app that I want to communicate with the desktop app, say via the loopback IP address, I can do that sort of thing. Enjoying all the UX enhancements that are present in the new version of Windows. And also enabling Windows on lower cost devices. Less RAM, less memory than was previously required. Let's see, I want to show you one more demo here. And let's see if we get the right device. There we go. So one of the things I wanted to show you is this thing we call Embedded Lockdown Manager. And what Embedded Lockdown Manager does is gives me the ability to configure this copy of Windows to serve as whatever device I want it to be. It's an Embedded Industry tool. And I can do interesting things with this, like there's a tool called a dialog filter. So how many of you have been walking around like in an airport or some public place and you see a machine with a Watson dialog up? Like everybody, right? You know why? Because they didn't turn that on. That's why. There's actually a setting to go turn those off if you don't want that kind, you don't expect that kind of user interaction. Similarly, with Windows 8.1 Industry, there's a gesture filter, because maybe if you're building a kiosk, you don't really want people to swipe to bring up the charms bar or swipe down to close an application. You have the ability here on a gesture-by-gesture basis, bottom left corner, left edge, top right corner, etc., to be able to filter gestures for a particular user. So for example, on a particular gesture, I can say, yes, allow or block these gestures based on the role of a particular user. Similarly, a keyboard filter. I might not want people to press the Windows key. I might not want people to Control-Alt-Delete. You can do all of this from within the Embedded Lockdown Manager. One of the cooler ones is the USB filter. You know, there's this attack vector of, there's this embedded device that happens to have, you know, a PC at its core, so maybe a POS terminal. What's to stop somebody from taking a USB key, plugging it into that device, and doing something nefarious with it? This feature actually prevents that. What I'm able to do, what it's done is it's read all of the USB devices I have currently attached to this particular device, and I can say, I can set that device up exactly like I want it. Then I can say, lock down everything that's not currently connected to this device. It was interesting as we were kind of working on this particular feature. Before we automatically locked down everything, which was good, except then when you reboot, you have a brick. Because you can't, like the keyboard, mouse, like nothing worked. So we thought, oh wait, maybe if it's connected, it's safe. And so we went that route. You could still, by the way, you can manually lock yourself out of your keyboard and mouse if you so choose. We won't stop that. There's a write filter. So with this write filter, we have the ability to get the machine back in a known good state based on reboot. So it's this idea that, like, I have this PC, it's in a public place, or a kiosk, or a digital sign, it's in a public place. People are going to mess with it. What the write filter does is says, yeah, people are going to mess with it, but then upon reboot, it will restore itself to a clean, known good state once again. And then finally, the Windows 8 application. What this will do is it allows me to choose a Windows 8 application that is the shell for this particular for this particular user. So for example, if I have a kiosk application, I'm able to do that. And I could say, yes, I want to configure a user. I want to browse local accounts. Let me see, I've got this kiosk user. And then let me go ahead and choose the default app that they're going to run. I happen to have this WB Retail Kiosk app. I'm going to say yes. And then enable. Now, what should happen is when I come back and I say, now I want to log in as the kiosk, instead of taking me to the Windows shell, it takes me directly to this kiosk Windows 8 style application. So that's the kind of feature. And if I had embedded, filters and all that, it might be that I can really limit the interaction modes to that which only makes sense for my application. A couple other cool things to talk about. One of them is Shark's Cove. I have one of the boards here. You can learn more about this one in the session on Friday at 2 o'clock. The idea here is this is really a tablet or laptop grade motherboard running a new Intel Atom series CPU. So I've got all the jacks to be able to plug in and do interesting experimentation with sensors and connectors. You'll learn more again Friday. I just wanted to give you the heads up that this is, if you're interested in kind of innovating in the tablet-ish space, that's an interesting builder board that you might want to take a look at. And finally, I'd like to end with this idea of Windows on devices. This is related to what Terry talked about earlier of running Windows, the modern Windows core on these tiny devices. This is a pencil eraser and the Quark system on a chip side by side. And what's important is that the 5mm, that is not the CPU. That's the SoC. That's the PC. 5mm is the PC. It's a very, very small PC. I have with me here one of these boards, and I can show you guys what that looks like. Switch over. So we're gonna look more at this in a second. But right here in the middle is that Quark-powered CPU. Let's learn a little bit more about that thing, though, before we go into demo. It's a 32-bit x86 chip running at 400 megahertz, one core today. A bunch of industry standard IOs that this thing is capable of, has a memory controller capable of accessing modern memory. The whole package is 15 by 15 millimeters, although the chip is certainly smaller. One key difference between this and other x86 variants from Intel is that it includes only the scalar instruction set, so it doesn't, for example, have the SSE MMX style instruction set. And the board that we were talking about, and again, this is the thing that was powering Joe Belfiore playing Heart and Soul on the piano, this is Arduino compatible. So just like the NetDuino that I showed you earlier, this is another approach to that open hardware platform, this time running a different CPU, only 256 megabytes of RAM, and then it's got USB and an SD slot, all the kind of things that you would expect it to have to be able to do your cool kind of makery stuff. But yeah, that's not a misprint. Windows running in on this device in 256 megs of RAM. We're really serious about bringing Windows to this class of devices. This is one example of a device in this category, but we think there's great opportunity in bringing Windows to this class of devices, which represent the small end of that big, broad pyramid of IoT devices. So let's switch over and start taking a look at this guy. And my machine is really enthusiastic about timing me out when it's time for me to time out. Let me close this instance of VS. All right. So what I have up, let me open up another instance of Visual Studio, and I just want to show you guys something maybe a little bit simpler. I've got this app I wrote called Quark Console, and this. Today what we have running on this device is Win32. You can imagine we do other things with it over time, but today, just to just to show you guys where we are in our process. We've got Win32 going. This is a C++, kind of your standard C++ application. Wanted to show you a couple things with this. One is I'm using Visual Studio 2013. I'm using the stock Visual Studio compilers. There's no like, didn't get a special build of the compiler or anything. I turned off SSE, of course, but that's pretty much the only thing I did for my application. And I'm linking to some different libraries that I'm using. What I wanted to show you is, one, this ability to use Windows types and make a Windows API call here, and then two, just emit some text to the console. If my window's still up, so this is a telnet window that's telnetted into my Galileo here. Here it is. So this is my Galileo device. And let's see, if I do, I've learned that this is the canonical way to prove it's Windows. Yeah, so it does have an instance of afd.sys. That's good. That means I'm running Windows. What I can do then is I can go back to Visual Studio, look at this console mode application. Maybe I can build it. Hopefully it builds. It's already up to date. I can maybe copy it over. What I have here is I have an FTP session. I've got this little test folder. And this is the output of where Visual Studio just dropped this. And yes. So if I drop this, yeah, this is my yesterday. Oh, because it didn't rebuild. You know what I'd have to do? OK, you guys are going to give me grief if I don't do it right. So let me do it right. Good. So now it's really compiling. OK, so now if I come over here, what I should see is, yes, that's it. OK, so now let's copy this guy over here. Yes, let's YOLO. We're going to copy over this. It's going to work great. All right. We'll go back over to my telnet window here. And let's see, I think I copied this to a directory called tests. Should look like this. I've got this quarkconsole.exe that has the I think it has the right date, or does it? Maybe. What's going on here? OK, Windows on Quark. Yeah, that's one issue. I have not set the clock on my Quark, and so it's a little bit confused, a little daytime confusion. But this is the app that I just wrote. I just deployed it over to Quark. Really, really, really fun, really exciting. We think there's a lot of opportunity to bring modern Windows to this class of devices. And I'm happy to talk more about this later as well. We're excited to bring modern Windows to these devices, but a whole bunch of stuff that I would just leave you guys with as thoughts. One is there's a whole set of things you can do today. Visual Studio, all the embedded stuff I walked through. Azure, we barely scratched the surface on, but if you go to Todd's session after this, you'll learn a lot more about that. All that you can do today. On top of that, we'll be talking in the coming weeks about more work we're doing for machine-to-machine services in Windows Azure, so stay tuned on that. You can get Netduinos, you can get Galileos today. You can go to your favorite retailer. You can buy them. They're in the range of $35 to $60, depending on what kind of version you want to get. I'd also invite you guys to get involved with us in bringing Windows to these little devices. So if you visit this URL, you'll have an opportunity to give us your contact info. We have a limited number of these boards provisioned with Windows. As soon as we kind of get all the fine-tuning done that we need to get done, we'd like to share them with you. And we'd like to get your feedback, and we'd love to know what you build with them. So if you're interested, I invite you to visit this website. And I'm told from the wings, HTTP, not HTTPS. Apparently there was a little confusion there. So HTTP, windowsondevices.com. With that, really would love your feedback on the session. I hope you had a good time. I had a lot of fun being up here with you. I hope you enjoy Build. I'm delighted to spend time with you. I'm going to be here till Friday. So any and every one of you, if you want to chat about this or anything else, please seek me out.